Good afternoon, everyone. Thank you very much for coming. So today we have a guest that we already had here a few times, and every time it's great to have Mark here because he always speaks with a lot of passion and a lot of knowledge on what he speaks, so it's great. I assume that most of you know Mark, but just I will mention Mark has very interesting past. He did physics and then math, but in recent years he's mainly focused on the environmental stuff, and he combined different disciplines with doing that. He had experience in CSIRO with UTS and a lot here at UNSW. And we asked Mark to speak a bit because of the election and to give his point of view, because he studied that a lot from the scientific point of view, so it's not only like waving hands, a bit of facts. So Mark, thank you very much for coming. I know that you did quite a lot of similar talk in the last few weeks, but hopefully with this audience we will get some interesting interaction. And just to notice, we will also mention the Miriam gang here, so we have quite a lot of people here from the neighborhood, so it will be great if you will ask questions as well, because part of this one is discussion with the public. Okay, let's welcome Mark. Thank you.
Thank you. Thanks very much for coming. I'm focusing on Labor because the election is coming. Labor has a chance of winning government, and the present government doesn't really have any substantial policies to achieve climate action. So Labor is going to be scrutinised, a bit of a critical evaluation, and well, you'll see. Also, of course, in this pre-election time, there's a lot of misinformation going on. A lot of myths are being spread and a lot of very strange statements. And I sort of consider this cartoon as a kind of example. Oh, yuck, a wind turbine. And if you're sitting up close to the screen, you'll actually be able to see the wind turbine, which is there. Anyway, so that's... But there are many subtle myths and misinformations being spread that maybe we can discuss afterwards. But I want to focus on whether we can meet Labor's greenhouse gas reduction target, which is a 45% reduction in emissions from 2005 level. So here is the Federal Department of Environment and Energy's picture of the Australia's greenhouse gas emissions. It's a pie, and you can see electricity is about a third of the emissions, according to this. Heat, stationary energy excluding electricity, is about 19%. So that'll be industrial heat, residential heat, produced in most cases by burning gas. Transport is another 18 or 19%. Then we have this funny thing called fugitive emissions, which are the emissions associated with fossil fuels. They escape from oil and gas fields, from coal mines, from gas pipelines, and so on, about 11%. Then there are industrial processes excluding the previous ones, excluding energy, so cement making, reducing iron ore to iron to make steel, and so on. And then we have a large segment from agriculture up here, and which I won't attempt to discuss, wastes here, and then the claim that land use and land use changes, apart from agriculture, actually have been a reduction in emissions of 4%. But I'm rather sceptical about that because it's very hard to estimate what these are. But anyway, that's what the government's estimate is. So I'm going to focus on electricity, and then you might say, well, why electricity? It's only a third of the emissions. Because electricity is the easiest energy supply technology to transition to renewables. And so the next step is not only to transition electricity as it is, but to transition most heat and most transport to renewable electricity, and that will also reduce the fugitive emissions. If you add up all the energy emissions, they're about 80%. So we go from 34% to 80%. So if we can address the energy sector, we're most of the way there, although agriculture does provide some problems. The main exceptions to electrifying transport are, of course, air transport and sea transport. And they will need the production of some kind of fuel using renewable electricity, for example, to split water into hydrogen and oxygen, either using the hydrogen or combining it with ammonia from the atmosphere, with nitrogen for the atmosphere to produce ammonia, and then ammonia is an easier fuel to handle. Okay, so if we look at the time trend of Australia's emissions from 1990 and then projected by the government out to 2030, the first thing you'll see is this great big peak back at 2000, it's really 2006, but very close to 2005. So you can understand why the government chose the reference as 2005, because it was pretty well the highest level of emissions in the past 30 years, pretty well. So since then, there was a big reduction initially in emissions, initially from reducing, apologies for that, land use emissions. That's the red on the top. Then we had briefly for 2 years a carbon price which substantially further reduced emissions from the electricity sector. The carbon price was then removed in mid-2014. Emissions increased again, and they continue to be increasing, although fortunately electricity emissions are still decreasing. But the increases in the non-electricity emissions are outweighing the decreases in electricity emissions. So here's more of a detail of the emissions by quarter, compiled from Federal Department of Environment and Energy. So here you can see from about 2014 the emissions trending up along here. Thanks to Hugh Sadler, we have this beautiful diagram of electricity emissions. That's the brown line at the bottom, and you can see that although they were decreasing before June 2012, the decrease accelerated during the carbon price. When the carbon price was removed, emissions increased again for a while, and now as renewable energy particularly grows, and to some extent energy efficiency, we see this decline in emissions from the electricity sector. We also have to think about exports, even though they're not officially included in our carbon emissions, which are done on emissions within the country. And the bottom line is that our exports of emissions at present, in the form of coal and liquefied natural gas, are about 44 tonnes per person, compared with our domestic emissions within Australia, which are about half that, 22 tonnes per person, roughly. So exports are important, and we have some moral responsibility that needs to be addressed, even if officially they are not counted. And of course, if the Carmichael mine and by Adani actually opens, they will enormously increase our exported emissions. Okay, so I'm going to suggest basically 4 goals for Australia's policy, and then discuss to what extent do Labor policies and the other policies of other parties actually help to advance this. So the obvious first one is to move to 100% renewable electricity as soon as possible. Maybe it'll be possible by 2030, but the barriers are not primarily technological or economic now, but there are some very substantial institutional barriers that we'll touch on later that won't be easy to resolve to go to 100%. Next step is to electrify most transport and non-electrical heat, and alongside that, of course, improve electric public transport and infrastructure for cycling and walking. So that's transport. Then, very important is to increase energy efficiency and energy conservation substantially. That is certainly on the demand side the cheapest way to go. And then last but not least, to phase out coal and LNG exports and replace them with gradually with exports of renewable energy, maybe in the form of ammonia. So they're my proposed four. There's actually five, because the second one includes both transport and non-electrical heat. They're my suggested goals. And I won't discuss the next slide in any detail in this talk, but we should keep in mind we need to address land use, agriculture and forestry, which are 17% of emissions all over, and some of these are quite tricky, particularly if we try to modify the human diet to become less carnivorous and so on, and to develop alternative industrial processes for making, say, cement and iron and steel and so on. I think it's also worth mentioning other strategies that must be addressed in the longer term, but many people would resist that, of course, because they go against the prevailing dogma in economics and in demography. We need to research and develop further the potential to transition to what we would call a steady-state economy. In other words, one that has low throughput and no growth in the use of energy, materials and land. And I'm thinking really here of the physical economy. I'm not so concerned about what happens with the monetary economy. It's the physical economy, the use of energy, materials and land, which really has the impacts. Although at present the two types of economy are of course intimately linked. And last but not least, another difficult one, where the issue has been polluted by Pauline Hanson and a number of others, but we really need to reduce population growth while maintaining multiculturalism and increasing refugee intake. And of course that is quite feasible. Refugee intake is a very small fraction of total immigration, for example. Okay, so no more about that, but just flagging them. So to move forward, we need targets, and we need targets not only for greenhouse gas emissions, but for renewable energy, for energy efficiency, for renewable heat, renewable fuels and so on. So we need multiple targets, as the Archer is facing, and we also can draw on a wide range of policy instruments. Clearly, it's very unlikely we'll have a carbon price in the near future, but so we have a big choice of remaining policies, which include other economic instruments, laws, regulations, standards, institutional change, planning, a dirty word in the neoliberal economics dictionary, transport and key industries. Okay. All right, let's get down to the parties. So the existing policies are as follows. The Liberal National Coalition have a nominal target of 26 to 28% reduction in annual greenhouse gas emissions below this peak around the 2005 level by 2030. They've ceased talking about 28%, so it's actually 26% it seems, and they want to partly reach that with Kyoto credits, which do not involve any actual emission reductions. They're an accounting device. The ALP has two main targets: a 45% reduction in greenhouse gas emissions by below 2005 level by 2030, and a 50% renewable electricity target by 2030. But I'm pleased to say we already have 19%. So that's not going to be very hard to achieve. The problem is achieving a 50% reduction in renewable electricity will not be anywhere near sufficient to achieve Labor's greenhouse target. And I'll go through some of the numbers fairly quickly. So, but first, let's look at 100% renewable electricity by 2030. Would 100% renewable electricity be sufficient to achieve the ALP greenhouse target? And I focus on electricity first because it's the easiest energy supply mode to transition. Well, there's been a lot of work here at UNSW simulating the operation of the national electricity market hour by hour for up to 6 years by Ben Elston, Ian McGill, Jenny Rees and myself over several years. And we have shown, and several other groups have shown, Andrew Blakes' group at ANU, Lenson's group based at Sydney University, the Australian Energy Market Operator, and others have all done independent simulations using real data on wind and sun and real data on hourly demand, that we can produce a reliable system with the vast majority of the electricity, the bulk of electricity, coming from variable renewables, wind and solar PV. And to make that system reliable, we need a remarkably small amount of storage, whether it's in the form of pumped hydro, shown in that picture, or batteries, or concentrated solar thermal power with thermal storage, or gas turbines or diesel generators running on renewable fuels. They all have some form of storage in there. So that is technically doable. Now, the total emissions in 2005 were about, depending on whether you take calendar years or years ending in September, which I've taken, which the government likes for some reason, the total emissions in 2005 were 605 megatons per year. The ALP target is equivalent to 333 megatons. Total emissions in 2017 were 536. So we're already quite a big step towards that target. Now we have to make some heroic assumptions. So let's assume 100% renewable electricity and no increase in emissions from the non-electricity sources up to 2030, which is a bit of a heroic assumption, taking into account current trends. And what we find then is that that will give us emissions in 2030 of 354 megatons. So we're getting close to the target of 333, but you can see that we haven't got there. And of course, our heroic assumptions are very unlikely to take place. So even with 100% renewable electricity, despite the enthusiasm of some renewable energy, renewable electricity people, we still need to do more to get even to the ALP target. We need, through energy efficiency improvements, through electrification of transport and heat and so on. Okay, I won't go through these figures in detail, but you'll have access to the slideshow subsequently, so you can go through them if you like. So with those assumptions, and if Labor only goes for 50% renewable electricity by 2030, its target, the bottom line is that there is still a gap of 147 million tonnes per year by 2030. So the 50% target is not nearly sufficient to achieve Labor's greenhouse target. Okay? Well, but we have a range of options for doing better. And I've listed a number of these options. They're not additive, right? Because you can't add up the totals, because doing one thing will affect one or more of the others. So, for example, increasing renewable electricity contribution and improving energy efficiency will automatically cut fugitive emissions as well. And electric transport emissions depend very much on the percentage of renewable electricity in the grid, because a lot of people will charge their electric vehicles from the grid, which currently is still fossil fuel dominated. But another positive thing to keep in mind is that if we can reduce fossil fuel electricity use by a given amount, in effect we're reducing emissions from that fossil fuel electricity by 3 times that amount, because the emissions come from the primary energy. You need roughly 3 times the primary energy to get electricity if you burn fossil fuels or if you burn any fuel. So there's some hope. So let's look very quickly at some of these. So the first one we've already dealt with. If we go from 50% renewable electricity to 100%, then we could save 91 megatons per year. So that's pretty good. All the more reason to go for 100%. If we go down to if we improve energy efficiency across the board by 20%, we immediately get a reduction, well, not immediately, but we get a reduction of 88 megatons per year. Pretty good, eh? Electrifying half of land transport and charging just with renewable electricity would give us a 35 megaton reduction, and so on. So we have a lot of options for not only reaching Labor's greenhouse target, but actually going well beyond it. I won't attempt to try and add up things that can't be added up. Okay, so we come back to these recommended goals, and I've set them out now as 5 goals. 100% renewable electricity as soon as possible, and maybe we could do that by 2030. Electrifying half of our transport by maybe 2035 at the latest, and improving infrastructure for public transport and walking. Electrifying half of non-electrical heat by 2035 at the latest. And when I give these dates, it means we have to get onto it right now if we have any chance of achieving those targets. Increasing energy efficiency and conservation by 20% by 2030. And if some of you had been to the expo yesterday by the Cooperative Research Centre for Low Carbon Living, I think you would have been very impressed by the huge potential for energy efficiency in buildings and in precincts and in whole suburbs. Some of the results astonished me, who can't claim to be an expert in energy efficiency, but really some of the potential is absolutely enormous on household, precinct and city scale. And then last but not least, phasing out exports of fossil fuels and replacing them with renewable energy exports, and that's going to take longer. So these results will take us well beyond ALP's emission target, these approaches, but they're not, I fear, all achievable by 2030. But we need to set these goals now and the policies to achieve them. And if Labor gets into power, into government on Saturday, it will need continuing pressure from you, the citizens, from us, the community, to really keep moving them to strengthen their policies. So I'm going to go through now the 5 goals, one by one, or my 5 goals, my proposed 5 goals, and the policies, mainly focusing on Labor, but mentioning briefly the Greens and the LNC, and making some comments. So for 100% renewable electricity as soon as possible, the LNC has no target and no positive policies. The ALP has a target of 50%, as you know, and it has a number of specific policies which will help move in that direction. So an extra $10 billion for the Clean Energy Finance Corporation, which I think is very important policy, particularly if most of that money is loaned for storage technologies. And by storage, I include renewable energy technologies that generate net renewable energy, but also have storage incorporated. $5 billion for new and upgraded transmission and distribution lines, also vital. Right now we have congestion on a number of transmission lines. There are regions, northwest Victoria, southwest New South Wales, the link between Queensland and New South Wales, that desperately need to be upgraded. And we have more solar and wind farms trying to feed into those grids than the grids can actually cope with. And it takes longer to build a major transmission line than to build a solar farm or wind farm. In fact, if you go beyond upgrading and build an entirely new high voltage long distance line, you're probably looking at 3 times the time required. And China discovered that quite a few years ago when they rapidly built wind farms, and at one stage about a quarter of those new wind farms weren't connected to the grid, but they have been building transmission lines at a high rate. So Labor has a number of good policies, but they're really not sufficient. They should increase their target for renewable electricity to 100%, and they should add reverse auctions, which have been so successful in the ACT and now being used in Victoria and Queensland to drive large-scale renewable energy. And those reverse auctions are particularly would be particularly designed to get New South Wales and Western Australia operating, because New South Wales has very little in the way of policies for renewable energy. In some way they've been fortunate that we are getting wind and solar farms in New South Wales, but I think that's not as a result of government policy, but as a result of the very high wholesale price of electricity, which means that it's highly economic to build these, provided they have the transmission. We also need a roadmap for phasing out coal power stations. It's one thing to build renewable energy, and the more renewable energy on the grid, especially, the more difficult it will be under current market rules for coal power, for example, to stay on the grid. But nevertheless, it needs a bit of a push, and there have been some very interesting policies suggested for actually giving a push to the dirtiest coal-fired power stations. But I won't go into that now. So the Greens do have a target of 100% renewable electricity, and their policies do address the grid transformation and the renewable energy zones that will need to be built as part of upgrading and renovating the transmission structure. Okay. Next policy is to electrify half of transport and improve urban public transport. And again, there's no target or positive policies from the LNC. The ALP has got a set of policies to support or to encourage electrification of road transport, and I've listed some of them there. I doubt whether those policies on their own would even achieve their modest target of 50% of new sales by 2030, but I suspect that global events will drive electric vehicles much faster anyway, and maybe we won't need a lot of policies. It would be nice to have policies for some fast charging stations situated at strategic locations on our main routes, particularly our main intercity routes, and the Greens are supporting that. But the way things are going, within several years, it's possible that the capital costs of electric vehicles will become fairly close to those of ICE vehicles. And because the running costs are far lower for electric vehicles, there could be a very rapid explosion of electric vehicles. So one has to hope that, because really the policies of the two major parties are not going to be sufficient. Okay, to electrify or solarise half of non-electrical heat. There are no specific policies from either of the three parties. Labor does have a policy called Safeguard 2.0, which is a fancy name for a baseline and credit emissions trading scheme, which is a strengthening of a similar scheme that the current coalition government has. The current scheme isn't working, but it's not a very rigorous one. So it's possible that some impact will be made from this safeguard scheme when it's implemented. The problem is that it basically is going to be directed at non-electrical emissions from those corporations that have emissions greater than 25,000 kilotons per year. So basically what Labor's doing is selecting the most powerful political lobby to challenge in order to get this, to apply this scheme effectively. And pardon my skepticism, but I don't think they'll be able to do it. It'll be there on paper, I suspect, but it won't actually have much effect. But I'd love to be wrong. The Greens are the only party recommending a carbon price, and certainly a carbon price would help a lot. And failing that, we need some specific incentives to encourage residential and industrial users to switch from gas to electricity. Okay, how are we doing? I want to leave time for some discussion. Increase overall energy efficiency substantially. This is again a seminar topic, or multiple seminar topics. neither of the three parties is brilliant on this. Possibly the LNC would have a tiny impact from their so-called emissions reduction fund, but I suspect that most of the energy efficiency improvements that that fund pays for would be done anyway on the basis of economic rationality. So it may be a question of just paying the polluters to do what they would do anyway. Pardon the cynicism again. The ALP has a general policy of permitting ARENA, the Australian Renewable Energy Agency, to fund via grants energy efficiency, and that's great, but it's very general. We really need some targeted policies for energy efficiency, such as strengthening the Building Code of Australia, otherwise known as the National Construction Code, both for existing buildings and as well as new buildings, strengthening minimum energy performance standards for appliances and equipment, working with the states to mandate energy audits and energy ratings and disclosure of those ratings of buildings when they're to be sold or rented, which is similar to the ACT policy that they've had for many years. Regulations for energy efficiency in rental accommodation, for roof colours, and so on. There's a whole list which we can't go through, but a lot of these are easy to do technologically and economically, but difficult to do institutionally and culturally. Okay, and then finally, phasing out the exports of coal and LNG while phasing in renewable energy exports. This is a huge challenge because it does involve some restructuring of the Australian economy. No policy from the LNC, no positive policy from the ALP, in fact, negative policies. They want to give $1.5 billion for gas pipelines in northern Australia, which would encourage fracking. And they haven't opposed Adani, but at least they're saying they won't fund it. The Greens have a set of strong policies, and the question is whether they, if Labor gets in, whether the Greens can actually influence Labor. So what we really need is strategic planning. Well, first, no new coal mines or gas fields, but strategic planning, economic and industry planning for how we can actually make this transition to produce exports of renewable energy, possibly in the form of ammonia. There was a scheme to build a transmission line from northwest Australia to Asia, but the proponents seem to have stepped back from that. It seems like it's more challenging than producing hydrogen and ammonia. Okay, so now I'd just like to talk very briefly about carbon budgets. Concept of carbon budget is that basically we can only emit so much more carbon into the atmosphere to, if we want to keep within a 2 degree C limit or 1.5 degrees centigrade limit. And there are a number of different ways of calculating how much carbon or carbon dioxide equivalent we've actually got left. And there are very big differences between them. So I'll start just by talking about the IPCC Intergovernmental Panel on Climate Change Special Report number 15 published last year. And they actually proposed quite generous carbon budgets. 1,170 gigatons, that's billion tons, of carbon dioxide for 2 degrees Celsius limit with a 66% probability. And for 1.5 degrees, down to 420 gigatons. Now, carbon dioxide emissions globally are about 36 gigatons, but of course that doesn't count some of the other greenhouse gases. So, one way of calculating Australia's share is what we call grandfathering, which is, in other words, based on our current emissions share, which is about 1.5% of global emissions. I'll comment in a moment about the fairness or otherwise of this method, but let's just go through the calculation. Then Australia's remaining budgets become 17.6 gigatons for 2 degrees and 6.3 gigatons for 1.5 degrees, starting from the 1st of January 2018. However, our annual emissions are about 0.55 gigatons, so these budgets correspond to 32 years for 2 degrees and 11.5 degrees at the current level for 11.5 years for 1.5 degrees Celsius. So grandfathering is pretty good for Australia. It gives us the most time, but it's unfair to other countries, one can argue, because it doesn't take into account first that Australia has been emitting at a high level for many years, so maybe we should look at our cumulative emissions. It doesn't take into account that we are the biggest per capita emitter, one of the biggest per capita emitters in the world. So what if we give equal per capita parts of the budget to everyone in the world? That only gives us 0.375% of global budget, or 4.4 gigatons for a 2 degree limit, or 1.6 gigatons for a 1.5 degree limit. And that leaves us 6.5 years for 2 degrees and 1.5 years for the 1.5 degree. And that's from now, not from the beginning of 2018. So you can see that according to this, reaching our share of the global carbon budget by equal per capita emissions, we haven't really got much time left. We haven't got a hope of reaching that target. And in fact, things are a lot worse, because I've chosen the IPCC 2018 study, but in fact, there are many studies that have been done, and many of them actually go into the black. So the shaded area are the areas where we've already globally exceeded our carbon budgets. This is for 1.5 degrees. And you can see there are quite a lot of studies there. I think there are 9. I'm not very good at counting. 3, 6, no, there's more. And there's a wide range of values, and that's because there's a wide range also of methods for calculating. So they can use the Earth systems approach, they can combine Earth systems with observations, or they can use integrated assessment models, and they all give different results. So it's quite possible that we haven't actually got any global budget left in the whole world, and that's a bit of a worry. Just show you one more diagram. This comes from a paper by Bahare Howard, Nick Hamilton, Tommy Wiedemann and myself, which was published last year, but we did this research before the IPCC special report came out with its carbon budgets. So we chose an existing set of carbon budgets, which was much more generous, very generous, and what we did here was we looked at 22 different scenarios for Australia, and we were only looking at electricity at that stage. And what we're plotting on the y-axis is cumulative emissions in gigatons versus years, and these are the emissions from each of the scenarios. And the horizontal line, the orange horizontal line, is the 2 degree budget according to the budget chosen, the rather generous budget chosen then. And the horizontal blue line, navy blue line, is 1.5 degrees. So you can see that quite a lot of the scenarios, and some of the scenarios we've taken from many of the groups in Australia that have done scenario studies, and many of the scenarios are our own. And so you can see that not one of our scenarios actually gets Australia within its share of the electricity budget. And here we're using the grandfathering approach, which again is very generous to Australia. The one that comes closest is one that we invented, which basically is 98% renewable electricity by 2030, plus really substantial energy efficiency improvements. I won't go into the details. So that's the one right at the bottom there that just about gets the 1.5 degrees. There are several scenarios to get under the 2 degree budget, which is encouraging. and there are many scenarios and business as usual that's up there that don't. Now I should say that we have in these calculations, Bahare Howard and her supervisors and colleagues have taken into account life cycle emissions. So we are particularly interested in the emissions involved in building the renewable energy technologies as well. And so they're included roughly. So the good news is that the emissions released in transitioning to 100% renewable electricity are very much less than the emissions saved by making that transition. They're very much less. So although there are emissions in mining the materials and constructing the wind turbines and solar technologies, as time goes on, more and more we are using renewable energy to build the renewable energy technologies. And that the result of that is that the emissions caused by the transition are very much less than the emissions saved. So that's the good news. The bad news I've already given you, that only one scenario comes close to the 1.5 degree budget. So I guess that's some food for thought.
So the inflection point for that scenario has to happen before 2025.
Very important point. So
the speed of transition it's a huge it's a big deal, and we actually basically report what others have reported. I think RElec, that's his last name, in Europe, and Riahi, several other groups, they all show that speed of transition actually matters a lot, and we actually got the same numbers. The speed of transition really matters.
Yeah, very important point.
Wait until 2025.
So
everything changes.
We've got to act very quickly. As Bahare says, if we don't act in the next few years, we've got no hope of, well, certainly got no hope of 1.5, but very, very limited hope of even 2 degrees. So that's, sorry to end on a sober note, that's it. But the conclusion is at least that 100% renewable electricity is feasible and affordable by the early 2030s, maybe even 2030. And with Labor policies and the states that are doing things, we'll probably achieve that or overachieve it, I would think. However, 100% renewable energy, which includes transport and heat, will take much longer and can't be achieved by Labor's present policies. And that's about it. So I hope we have some time for discussion. For those who want some background information, my book is Sustainable Energy Solutions for Climate Change, but it doesn't deal with the current issues. And I have a paper published by the Australia Institute at the end of last year on electricity policy for Australia that expands on some of the issues and some of the non-technical barriers that exist even going to 100% renewable electricity. So thanks very much.
Richard.
Yes, Richard.
Mark, thank you very much. Both challenging and inspiring, both. With the sort of approach that you were taking with the energy infrastructure, with I think one of the latest slides where you're looking at the impact of building it, and
yes.
Then I've got no problem with that approach. But have you or anybody else taken a similar look at the energy efficiency from the same point of view? So I guess I'm thinking about the transport particularly, and we've gone to electrify transport. I've been watching it happen outside our door for the last 500 years or so, and perhaps we'll see it for the next 500 if I live. And the millions of lawyers that are living the high life off it, and the concrete and the steel and the resources that are going into that over and over. It's probably got a quite long payback time, I guess.
We haven't done that, but a number of people around the world are looking at that, and certainly Tommy Wiedman at this university is looking at some aspects of that. A lot of attention has actually gone to the built environments rather than to transport. So with the built environment now, and I'm drawing upon yesterday's CRC Expo, there is huge potential, and there are sort of standard figures for lifetime energy use of different materials, life cycle energy use of different materials, but of course these are rough figures. It depends on location very much. It depends on where the manufacturing is done and how much transportation there is and so on. So I think this is an important field, and it seems to be rapidly expanding, and there are a number of international leaders like Hertwich who are rapidly increasing our knowledge in this field. A lot more needs to be done because there are some critics of renewable energy who claim that that the energy, they're not so much concerned with carbon, but they complain that the energy return on energy invested for a renewable energy system is low, much lower than for fossil fuels. And in fact, I'm drafting a paper along with some of my colleagues on this. There are some misconceptions. The people who are making these claims are mostly economists who don't necessarily understand the physical processes very well, and they make a number of assumptions which are unjustified. So for example, they assume that the energy return on energy invested of technologies like solar PV, that energy return is going to decrease with time. Because presumably that's what happens with fossil fuels. The more you dig out fossil fuels, the more you have to go for fossil fuels that are harder to win. But in fact, as you know, and everyone here I think should know, the cost of solar PV has dropped dramatically by a factor of 10 in the last 8 or so years, and that cost reduction has to reflect to some important degree the reduction in the use of materials and services used to produce the technology. And in fact, one of the methods of life cycle assessment is to purely base it on input-output analysis with costs, because the problem with trying to use a purely physical approach in terms of measuring, accounting for materials is that you have to make a cut-off somewhere. I mean, you've got to mine the materials, and then you've got to consider the energy use that goes into building the mining machines, and there's an infinite regress. And using input-output analysis is actually, in some ways, much more realistic. So sorry, I've probably spent too much time trying to answer that. Just to summarise that this is a very important issue and it needs more work. Anne?
Have you got any big ideas about the decoupling of the physical growth in the physical economy from growth in the financial economy? I mean, there was actually at the expo yesterday, one of the speakers, I've forgotten his name, is actually measuring scope 3 carbon simply by the cost of the product.
Yes.
Which is a pretty big assumption.
No, that's the assumption that...
But I just wanted to, so in that field, maybe even linking up with what you just said, have you got any big ideas on how this...
Well, I'd rather defer that by saying that at this university there's a group of interdisciplinary people who are looking at a steady-state economy and how to transition. And in fact, we, one small member of that group, have produced a book about this, which I can point you at. So they involve mathematicians and engineers and economists, and interesting bunch of people looking at how to transition to a steady-state economy. And there have been 2 major studies in the world that I know of, one in Canada and one in Australia. And the Canadian study was done by environmental economists, and they found that simply stopping the growth in GDP, of course, throws out many people out of work and is an economic disaster. But if it's strategically planned, combined with other policies, such as building up the manufacturing capacity of your own country, so you're not importing so much, and spreading the work around by minimum income and things like that, they found that by combining it, at least according to their macroeconomic models, a steady state economy would not necessarily involve an economic collapse and so on. So there's interesting work going on. And in Australia, there was work done on the physical economy. And in fact, I played a small role in one of the papers in that, where we examine what happens to employment and so on, purely based on input-output of physical processes. And again, similar results were obtained, provided you have a whole range of policies to spread the work around and build up local capacity, so Australia just isn't a quarry for the rest of the world. It is possible nationally to build, in theory, a steady state economy. But of course, we didn't address the difficulties of what the interaction of a steady state country with the rest of the world that isn't steady state, which is non-trivial.
Bjorn?
Yeah. You mentioned that in 2006, was it, they had input into a carbon price in Australia?
Sorry, 2012, mid-2012 to mid-2014 was our brief carbon price.
Okay, so, and you can see from the graph that actually works, right? And it goes, like, the emission was
it works
going down.
very well for electricity.
So what would be the barrier to reintroduce it once?
Well, it's political barriers. So a certain
what
politician
political power put into place the first time?
It was introduced by Labor with the Greens pushing them very strongly, and then a certain politician had a slogan, axe the tax, and so on. Actually, it was rather funny. Somebody just told me today, I don't know if this is fake news, but apparently Tony Abbott is so desperate to retain his seat of Warringah that he made a public statement, and please check if it's true, that Labor has better climate policies than his own party. Now, please check if that's true, or whether somebody's just circulated some fake news. But anyway, if it's true, it would be the ultimate in hypocrisy.
Mark, I've got a related question.
Yes.
The University of New South Wales has produced this.
I can't read it.
Right.
You'll have
It's
to read out.
a climate dividend for Australia.
Yes.
Right.
Yes. This is a carbon
And
price.
this was launched by Dr. Karen Phelps. It's one of the things that got her elected, frankly. But you think there's no chance in the near future of something like that being adopted?
Well, to say that there's no chance is probably unwise, but both major parties have come out very strongly against any sort of carbon price, except when they label some of Labor policies unfairly as a carbon tax, which they're not. The dividend approach basically is to put on essentially a carbon tax, but the dividend part is how you handle the income from that. So you redistribute it to all adult citizens. So it has the advantage, you can say to people, well, you're not losing anything, and in fact there is a gain for low income earners, depending on how it's redistributed. So look, it's one approach. It's an approach that James Hansen supports in the United States, and I think he was one of the original pushers. Persuading isn't something... Persuading with logic doesn't very often work in politics. Persuading by not electing people is what counts. Persuading industry by not buying their products or buying alternative products can have a lot of impact, and you've got to have a rational argument, but a rational argument alone cuts no ice in Parliament House, unfortunately. That's my impression.
So let's have just last one question. Mark will be here outside, I'm not sure if there is someone after us. So
Yes, look, thank you. It's been very inspiring hearing what you have to say. But coming from the everyday person and the all or nothing approach that is now existing out there in society, Bob Brown's recent learning curve, shall we say, with the Adani going up to teach the people about a better world, and they're saying we have to live off what we have as an economy.
Yes.
There's a lot of people stuck in that reality, and that's what is being exploited by the politicians. Therefore, I really applaud the education around steady state. I'd like to learn more about that, because it strikes me there's an education in that which can go in tandem with a lot of the issues that you have put forward. And the reason why I state this is, I don't know whether people are aware, Greenpeace has just released a phenomenal documentary on the stranglehold of the neoliberal coal owners, politicians and lobbyists, which puts Australia in a dreadful, dreadful state. So there's an ideological war going on, but I feel with the rise of civil society, understanding steady state and beginning to look at how we can transition will help people come with us.
Yes.
Do you feel that I'm off beam when I say that?
No, you're right on beam. However, many of us would contest the idea that's been spread widely in the community that we have to choose between jobs and the environment, which,
I couldn't agree more.
you know, and I think it's very important to stress that there are actually far more jobs per unit of energy in renewable energy and energy efficiency than in
So
fossil
that would
fuels.
be contained in your steady state theories, wouldn't it?
Well, jobs, yes, so steady state economics.
So I think we need more of that in civil society for people to
Yes.
truly grasp it.
Yes, and there needs to be a lot of emphasis. I should have emphasised that with the two macroeconomic models of steady state economies, the Canadian macroeconomic model and the Australian biophysical model, in both cases there were more jobs. More jobs could be created with the right set of policies. But what you can't do is just say, let's stop economic growth and do nothing else. It's a complete disaster. Yes, so thanks for your comment.
Thank you.
Okay.
So that we can talk about redistribution with steady state.
You can certainly have redistribution.